Okay, we're going to look at some distributions and some numbers associated with it, such as measures of center, the mean and the median, which you should know by now. The mean versus medians, see how they differ a little bit when you do distributions and which is better in which cases. Measures of spread, we've already looked at quartiles and a little bit of standard deviation. And then we're going to get into a 5-number summary in the box plot and choose among which of these summary statistics. And when you do something like an average, it kind of sums up what you have in some manner. So the mean we've already had. It's called X bar. This is the mean for the sample, not for the population. And we want to write this short as we can. So this might be one way of doing it. Over here, we've actually gone to algebraic notation, where x of 1 is just the first number we're looking at. X of 2 is the second number. N is the number of samples we have. The number of objects we're looking at in our sample. A lot of times we actually call it how many samples we have. X bar is equal to 1 over n. That's the same as dividing by n. Multiplying by half is the same as dividing by 2. So if I'm looking here, it might be dividing by 2. Here I'm multiplying by half. This is capital sigma, which is shorthand for saying the stuff up here at the top. All these added together. So what do we mean by resistant? Suppose I have 3 numbers, 40, 50, and 60. The median is 50. The mean is 50. And now I take 40, 50, and 60, and I add another number to it, such as 1,000. So I now have 4 numbers on my list. The mean changed quite a bit, so it is not resistant. The median did not change, or did not change much, one of those two usually. So it is resistant. So we've gone over how to find medians. You can stop this if you need to and reread it. So here we have a list of data. The most common mistake is students assume the data is in order. And you'll see, in this case, to find the average, it doesn't matter. But now, in order to do a stem plot, to find the median, the quartiles, you actually have to put it in data. Here you see this 0, 5 corresponds to the 5. The 1, 0 corresponds to 10. 1 and the second 0, the second 10. And the 5s here, there's 4 of them, there should be 5 15s. And if you check this carefully, there are. A lot of times people will leave this one out and this one out because there's nothing there. So the median, you can find by counting in here. Usually people will just take this whole list and put it in order. So if this is actually completely symmetric, the mean and the median will be the same. If it's skewed to the left, then you'll find that the mean is typically the one on the left here. The median will be the one on the right. And the reverse is true when it's skewed to the right. Measuring spread. We've already done the quartiles. So I'll go through this, but again, this is one where you need to stop it and check it yourself if you're not sure what you're doing. And we want to find that interquartile range for another purpose later. Here we have 5 numbers. Min, Q1, Q3, the median between them, and then the max. We're going to make a box plot. And the box is going to be pretty simple. It's the left and right hand side if you're doing it horizontally. They're going to be Q1 and Q3. The line through the center is going to be like the number line. The median is going to be inside the box because the median is always between Q1 and Q3. We're going to extend our lines out to the minimum and maximum values if they're not outliers. Now we're going to have a rule to decide whether they're outliers or not. It's just a practical rule. We take the interquartile range, that's the difference between Q3 minus Q1. We're going to multiply it by 1.5. We're going to use that. I'm going to say something like this. If I take Q1 as 15 and I go to the left, 1.5 times the IQR, anything to the left of that is an outlier. If I take Q3, which is 42.5 minutes in this one, and I go to the right of that, 1.5 times the interquartile range, anything to the right of that's an outlier. So here's the numbers that we get when we do that. So you can already see here, you get into the negative range, and this is minutes, so this is not going to be included. Here's our list. There are no negatives, so There are no outliers to the left. We calculated the 1.5 IQR plus Q3. It said anything to the right of 83.75 minutes is an outlier. We have a number 85, so we have an outlier there. Here you can see them put into order. There are 5 numbers. You notice that this is our max that's inside, not considered an outlier. So this dot, when it's by itself, not on the line, is automatically an outlier. Let's stop this for now.